Hello, chi rotational motion adinga fourth video na last video hitan. Chila hi equilibrium to rolling motion topic a question ding solve the theory concept jang involved na. Okay, so let's see. Masapena cho equilibrium question na chi chapter ko na yang ki do ala chun. Hi question solve na dinga chu ipp ngai cham. Na ai lo le chun thil khat chu na rigid body khat chu equilibrium a hong ma la chun. Hichi awam na chu condition chu EPP ngai cham na. So what are the required condition for a rigid body to be in equilibrium? Okay. Rigid body khat chu equilibrium awam na dinga chu condition ni ngai cha cho ma sapen chu piham tele. So the net force will be 0. Okay. So net external force on the rigid body should be 0 and in pen chu net torque should be 0. Okay. Rigid body khat chu nga chu net force 0 hiya net torque 0 hi la chun chi body pa chu na equilibrium awam di chu. Okay, so rigid body khat equilibrium na dinga chu condition ngai cha chu pham tele net force 0 hi ngai chu ke le net torque 0 hi ngai na chi ja chu chelai chapter ko na equilibrium question hum ki dong hoi na solve na dinga chu step ni ngai cha cho. So first step number one chu pham tele ma sa pension net torque equals to 0 bol ngai na summation of all the torque acting on the body should be 0. Okay, example the torque hard knee thumb. Okay, suppose you have 3 torques. So torque 1 plus torque 2 plus torque 3 should be 0. Step 2 na chu net force 0 hi ngai na. Step 2 cha chu summation of all the forces equals to 0. Okay. Chilai condition te ni na chite ni question jau san apply dio. Okay. Question abang bang chuna hang pia question hoi JEE means to NEET level question hoi na. First pa bo se he apply la chun answer ang pot de beta. Okay. If also leather problem ki dikha na leather problem aku alang pi ai ani ai ki apply na. So both of the steps you have to apply. Okay. Abana second thing chu net force 0 hong ki ti phal hin hoi chi pen ha x langa ham y langa ham z langa ham. Okay. So here net force equals to 0 ti pidinam dela. So here along the horizontal also net force is 0 na vertical langa jong chu net force 0 heading chukil le z axis langa jong net force 0 ti nai chu. Okay, net force 0 hit chi pitinam tele. So net force is 0 along the x, along the y, and along the z. Okay. So hang pia question hang pia ako question ako force of si hu x axis lang cos. Okay, ala sun net force fx equals to 0 na bol here na. Force of si sun y lang cos so ako so okay vala sun fy equals to 0 na bol here na. Okay, so we'll solve questions so you will understand. Okay. Okay, so to solve equilibrium problem, remember step 1 na net torque equals to 0 bol deu, step 2 na net force equals to 0 bol deu na. Okay, so let's see. For example, hitia hi chi roof cho na roof apara hi I have a rod, let's say. Okay, so there is one rod pa hi aning te nya hi khawang ke khai la cho. Okay. So you have two threads to the two strings na string ni akuna hi rod to aning ninga ki hit cho. Ala tu hin a rod hil hale chun hitai dan ne chuna equilibrium ma chang la ta cho rod cho. So here we know that the rod is in equilibrium. Atila chun chila equilibrium hi la chun tension ten hi pp hidem. So what will be the tension on the string? So that is the question. Okay. Hitia hi body khadong ki piting in tension force a helole na normal force ti havel ki dong je equilibrium question ai na. Suppose let's say the rod is mass m. Okay, mass small m, length jong chu small l tu na. Question chu piham. So what is T1 and T2? Okay, find T1 and T2. Tang free body diagram ga zile hen rod chu ta yom cho na rod hi ta yama. So tension khat pa kho chilangai tension T1 ma tension T2 chila he om na. Abale tang rod chun mass anai ja so weight jong om ngai chila na. Weight chu hela yam ding ham center of mass am de cho. Center of mass so lai ta hi. So here we are taking a uniform rod. Okay, uniform rod hi ja chu center of mass lai ta om na. Ale hin to hi value chun step 1 chu pha step 1 chu solve na dinga step 1 pa chu. So here net torque should be equals to 0. Okay. Khutile chila hi torque is anumam. Torque si value hen tang torque ti chu if the rigid body rotates about an axis of rotation na. Axis of rotation chu ngai te so torque hol na dinga chu na. So here see important thing is we have to put one point as the axis of rotation. Okay. Chilai la hena. Rod chunga hena nom na layo na. So any point you want in the rod, you put that point as the axis of rotation. Example chu chilai axis of rotation ka tiala chun. If torque T1 pa hen rod pa hi clockwise rotate good na. So it will try to rotate along the clockwise and torque tension T2 will try to rotate the rod in anti-clockwise direction. Okay. As it center of mass pahi axis of rotation ka assume na. So if I fix at the center of mass, that is the condition. Alato hi chilazon ka fix thaicho. If I fix here, so this T2 will try to rotate anti-clockwise, MZ will try to rotate clockwise na. Ay wang chilai ka fix ala chun chilai T1 pahi pi ha. T1 pahin a rotate thilo chula na fix point la ya pass a force pahi. So there will be no torque due to T1. Okay, remember. Hichelai fix point kala ala chun hilai axis of rotation kala ala chun hichelai force pass na hichelai kuna torque ma sam na so. Okay, similarly, if I take this as fixed point, so there is no torque due to T2. So torque is due to T1 and torque is due to MZ. Okay. So I advantage kharom so chilai question na heavy chun T1 to T2 hold chula na. I want torque equals to 0 hi equation khat bo se chula. So therefore, I will pick the axis of rotation, the fixed point, in such a way that it will eliminate one of the two forces, unknown forces na. Chilai T1 to T2 ka hello chula chija chu fixed point pa he na axis of rotation pa he chilai T1 kala chula he. As T1 kala chun to he torque due to T1 he na 0 ta chula talaw na. So when I write the equation, see MZ will try to rotate clockwise. Let's say this is torque T1. Okay, tau 1 na. T2 hin anti-clockwise rotate go ding tin tau 2 tiu. Achi pen here. Ale chila hin net torque chu pi ham. So net torque will be so tau 1 plus 2 equals to 0. Okay. Ale clockwise pa hi positive assume tin anti-clockwise pa hi negative assume tin na. As is torque to axial vector chila. So here torque is what? R into F perpendicular na ilole R perpendicular into F. Okay. Atile chila hi R hi pp ha. So MZ hi it is at a distance of L by 2. Okay. And then T2 is at a distance of L. Right? Kutile torque chu pi ham. So tau 1 chu L by 2 into force to MZ na R into F perpendicular L by 2 to MZ hi perpendicular sa ta chu chala hi. So minus khat pa ko anti-clockwise sa so minus kala de na chala hi. So L into T2, so this should be equals to 0. Okay. So from here, what is this? LMZ divided by 2 equals to L into T2 na. L cancel lesson T2 sujarang ponam. So T2 is equals to MZ by 2. Okay, so this is equation 1 tiu de. T2 chu ki heta na to he. Ale T1 holding chu next step chu bi ham. Step number 2 chu so net force equals to 0 I apply to chu chala he. Okay. So net force equals to 0. Apan chalai force jo si hevela jun T1 to T2 jong hi y lang a chi na MZ jong hi y lang am. So therefore I can write here Fy equals to 0. Okay, I'm vertical lang net force pa na equals to 0 to ka equal din na chu chala he. So what do you have? So T1 to T2 who upwards na upwards equation plus nui lang ko solution minus. So minus MZ should be equals to 0. So like when I hit T1 hold na. So T1 is equals to what? MZ minus T2. Okay, T1 to T2 to MZ to Z lang transfer le na. Is that the so MZ minus T2 who equation 1 apan ako MZ by 2. So therefore how much is this? This is MZ by 2. Okay, T1 to na chala here. Okay, so now you have T1 and T2. Okay. Aba na question khan bol beta na chala here. Suppose same question. Roof upper ako rod khanung ki khail ha chona chalai rod hi. So let's say one rod is here. So rod to mass M, length L na chi chunga ru roof cho chalai. So to hi chilang string pa hi aninga ki khan na chi. Ai wala khalang spring pa hi. So it is now attached at a distance of L by 3 tiu. So random distance na. Atila chalai jong hi same question, what is T1 and T2? Hichi practice na ibolo jo chalai he. Khotile itang free body diagram ka jilo chon. Itia he road cho na che road ma chilanga he T2 ma. So distance L by 3 achu T1 cho. Ale T MZ cho hela am de alai tam na MZ cho. So MZ is here, okay, downwards. So khotile fixed point chu ti la deu ha. So unknown point chu T1 to T2 chu ki hello jula na. So you take the axis of rotation, the fixed point at T1 or T2, anyone, okay? No, pen choose now. As well as T1 ila zi was try T2 ga allow na je. So let's take this as T2. T2 ki fixed ta cho. Okay, fixed ala chun. So the torque due to T2 is 0 na. T2 hin apai thilo ta cho la ji T2 chu axis of rotation pass through ji acho na. Okay, then MZ is at a distance of what? L by 2 na half. T1 pa hi T2 upper hi zat ham axis of rotation upper hi so 2L by 3 na zi chu hi chi hi L by 3 chula chi L by 3 hi la chun hi chi like up and chu L minus L by 3 chi chu 2L by 3 okay. So let's say you see T1 will try to rotate in clockwise direction now about the fixed point okay. MZ will try to rotate anti-clockwise direction MZ pa hi T1 lautin T1 una pa hi tau 2 lautin na khutile step 1 chu pitam step 1 chu so net torque should be equals to 0 okay. Net torque 0 hi ngai na chilai torque is mam torque ni ta cha so tau 1 plus tau 2 equals to 0 so tau 1 ko piham so tau 1 ko due to MZ chula na so minus L by 2 into MZ R into F perpendicular minus hu anti-clockwise hi ja na so plus khatpa hu 2L by 3 into T1 so this is equals to 0 chilai ko na ping podam so 2L by 3 into T1 LMZ by 2 pa hi khola transfer lejon LMZ by 2 so LL gets cancel out T1 ko jan pora T1 chu so 3MZ by 4 okay. So equation 1 tiu na chala hi ale T2 holding a step 2 chu piham step 2 chu so net force equals to 0 okay. So force of C value on vertical ngan chang chula na y axis lang ngan chang so therefore Fy equals to 0 okay. Kutile chila hi T1 to T2 hu upwards na chija cho plus MZ pa khonui lang chija cho minus so T1 plus T2 should be equal minus MZ should be equals to 0 T2 hold na to he so T2 is equals to MZ to T1 khola transfer le chun MZ minus T1 so MZ minus T1 cho piham so 3MZ by 4 okay. Equation number 1 apan ako na chi za no pot diam so this will be MZ by 4 okay. So this is T2 okay. T2 and T1 na okay. So hang pia he chi equilibrium question jo si solve dan pa he na chi jo step nia ki solve so hang pia question nob dio khona step 1 bo se apply le chun step 1 akona jong hi answer na mu mai theo na abang bang step 2 chan na chiu ngai jong hum ngai the cho jala he okay. So now let's solve the actual previous year's question chi hi Z means 2025 question na so uniform rod of mass should be kpm 250 okay. This is mass length is kpm 100 meter 100 centimeter na so is balance on a sharp edge at 40 centimeter na so balance ki koi cho thikhan aki do na so a mass of 400 gram is suspended at the 10 centimeter mark to maintain the balance of the rod the mass to be suspended at 90 so it is something like this okay. A whole diagram pa cho na hitai rod khan cho rod pa cho hilai ki balance ha thilkhana ki balance na jara he so let's say here okay. So it is balance here thikha ki do ti na cho aki the wala chun force I apply is na reaction force normal force I apply is jara chun so this is at a distance of 40 centimeter na jo thilkhana ki do na ro chu ala chiti lo jo dang ki pia so let's say here 40 centimeter 10 centimeter mark na jo thilkha ki khaila chula na jara he 10 centimeter mark acho 400 gram khat ki khaila cha chala he so here so something is hanging here okay. So this is 400 gram na chipen hi 10 centimeter mark oh ala chun question chun pi do he chi balance na ding acho na 90 centimeter point a hi chila hi mass is ar khaila ngai ham ti chun so let's say mass is m then the weight will be mz na so ani na pa hu 90 centimeter okay. 90 centimeter acho batang measurement jo si hi chilai paran chilai reference na la wal chun bona chilai ko na measurement na bol de chilai he okay like this right. So we have to find out capital M so you draw the free body diagram hita hem chana rod ita ma so batang ma sapena cho weight cho helam de ha middle arm chana middle point a so mass to 250 hela chun 250 chu pi ha bonin gram in mang tena option chung gram am chala so mz means how much so 250 in 250 so mass is that into 10 bolas and 2500 okay. Newton is in kg so let's convert in kg na chipa he 0.25 kg tina cho che bale khat pa chu 400 gram to 0.4 kg okay. Khutile chala he a weight pa he is that ham 2.5 newton na chala he weight pa chu 2.5 newton at a distance of is that ha chi L by 2 na abana chun khara 90 centimeter mark achu mg tiu ta chalai mg abana 10 centimeter mark achu zat ham for 0.4 so mass za weight to 0.4 into 10 na mg, so that means 4 newton. Okay, aban le aki balance na la ya chu hi chalai pa hen na hi pa hen hi rangai force khat apply chu. Okay, so let's say there is a normal n na n khat ga tiu te 40 centimeter mark achu, so one force n is here. Question chun pi do ham question chun m do na to chu tang unknown ni ta amjula chela hi, so therefore you take the axis of rotation in such a way that you can eliminate one of them na hichi ke eliminate hi hello chu ji m as chu m pa hi hold do deuza, so I will take the axis of rotation all of the torque about this point. Okay, as a fixed point pass na axis of rotation pass chelai ka thena la chun, so now the torque due to n is 0. Okay, now n is kimang talo chu n chu. Okay, so here betang 4 newton pa hi 4 newton pa hin about the axis of rotation, it will try to rotate anti-clockwise. Tau 1 tiute. Mg pa khun clockwise a rotate good na, chu tau 2 tiuten. Capital Mg pa khun clockwise a rotate good ding, chu tau 3 tiute. To he torque thum da chu, force thum ja chu. Okay, and next is betang measurement jo si hina r value jo si about the fixed from the axis of rotation to the point where the force is applied. Hi chu hi chu ajala he. Khutile 4 pa hi is that haji chi 10 chuna chi 10 a hi la chun betang chilai para hi chilai hi is that haji, so this will be 30, right? Because this is 40. Okay, so first part this is 30. Abana chu mg pa hi oh is that amdha, so mg pa hi is that haji, so here see total length chu 100 chula na 100 hi la chun chilai para chila hi 40 hi za mg chu alai ta am chu alai ta hi na, so that means this is 50. Okay, so therefore this will be how much? 10. Okay, mg pa chu axis of rotation apara chu 10 centimeter gamla na aban la chun capital mg pa khoi jana gamla ham ta chelai measurement ka ai phat tham ala mai thena hi jong le I bol te ngai chu chelai he chi axis of rotation chelai hi jana chi khutil remaining si hi za dhya chi 60 chula na total chu 100 hi za chi 40 la chun chi 60 ai wan chu chi jong hi za dha chi 10 hi chula na aji chu butang hi chi 90 ki pi chula che pen here, so this is 90, so therefore this is 10, so therefore this is how many, so this will be 50. Okay, kutile che pa hi 50 am na jela hi. Okay, now let's apply the two equations, step 1, step 2. Okay, step 1 chu pi ham net torque equals to 0. Anti-clockwise ho chu minus kala, clockwise ho chu plus kala. So chala hi. No bole anti-clockwise ho plus na la wa, clockwise ho minus na la theo na. So it is up to you. Okay. So tau 1 plus tau 2 plus tau 3. So this is equals to 0. Tau 1 ho pi ham r into f perpendicular. So 30 into 30 ho centimeter is also meter ko convert 30 by 100 kati de into 4 to 4. Okay, this is minus na anti-clockwise. And plus tau 2 ho pi ham due to the weight. So 10 centimeter, okay, into 2.5. So plus tau 3 ho pi ham, so 50 centimeter into mg, force mg na. So this is equals to 0. Okay, now you solve this, you'll get n. So this cancel out. So 4 are 12 by 10 to pi ham minus 1.2. Okay, plus. So 0 gets cancelled out, which is 0.25. Na 2.5 divided by 10 to decimal point left lang transfer leuchen. So 50. So here see z is also 10 na. Z value jang put ngati asela here. So 0 gets cancelled out. So I have 5m. So this is equals to 0. Okay. To solve leuchen sa pot di ham. So minus 1.2 minus 0.5 so piha. So minus 9. 9, 10, 11, so 5, 9, 0.95 minus 0.95 plus 5m equals to 0. Okay. Atile, so 5m equals to transfer 0.95. So therefore, what is m? So m is equals to 0.95 divided by 5. Okay. Nhe di hoje chipen kg na lai so chipen kg na option ko value gram yan changa ke pi cho khotila gram yan changa ke pi cho 1000 to multiply bol cho na chila hi. So how much will you have? So mass is equals to, so 0.95 in 0.95 into 1000 so 950 na ji. So 950 divided by 5. So how much is this? 5 1 is 5, 5 945. So 190. Okay. So 190 gram. To hai gram ta so. So the answer is option C. Okay. Chi question hi value chun step 2 ke apply lo na chila hi question abang bang kho lang pia G mains to ni level question hoi na. Step 2 chan ho na chiu ngai lo mai the cho. Question asu ha mong wala chun na step 2 chan na chiu ngai dia. So here in this question you see you don't have to go to step 2. Okay, step 1 apply m value ke mo jing ta cho chila hi. Okay. Next question. Chi need exam question na. Value chun masapena chu pkpm rod mama ke piket na length chu 20 centimeter. So mass to 500 gram. Okay. So a mass of 2 kg is suspended in the rod at 20 centimeter mark. And another unknown mass of m, unknown mass mama na chuna. So 160 mark I suspend. 160 total length to 200. So here, how much is it? Find the value of m. Azo ki bang na question cho. So here figure is given. Okay. Chala value chun 2 kg chu chala ki suspend na at 20 centimeter mark. Okay. Abana cho 40 centimeter na hi tahi ki do cho til khara ki do na chala hi. Abana 160 na chu. So at 160. So now this is some mass m na. Question chun mass m chu zat ham ti cha. So same question na. Free body diagram zile chun. So I have a rod here. Okay. So rod a chu 20 centimeter a chu is that ha chi. So 20 newton na. 2 kg chu mg chu 2 into 10 to 20 na. Abana chu a weight chu hela yam ni ha alai ta hi. So mass chu 500 grams chu 0.5 kg na. 0.5 into 10 to 5 newton. Okay. Abana chu at a 160 mark, so you have mg. Okay. Force dang bimam akido na ako na ako normal force ka apply ke na ji and do da jara. Khudile distance chu biham batang fixed point chu helai ki do ha ke bang chu. Mi holo diu ji chu n pa hi hol ngai lo na. So we'll put a fixed point here at end. Okay, let's assume that the whole thing is fixed at end. Okay. Athile chun distance ho heza de ha. Masapena 20 pa heza de ha na hi. So here this is 20. Okay. So this is 40. Chisa chu chi pa heza de ha chi 20 hi ngai na. So therefore this is 20. Abana weight mg pa hela 5 newton pa hi is aram ha. Alai ta am chula na mg chu. So alai ta chu ha 100 chula alai ta chu 100 mark na chi. So this is 100. Total length 200 hele chun. To jo ki fix na hi ha ki fix na hi 40 chula na chi. Chi 40 hele chun aman ki ka distance pa hi ha. So this has to be 60. Okay. Diagram pa hina accurate chalo me the chi jong le. So we'll have to understand it. Okay. So this is 60 centimeter. Okay, bana chu how much mg pa hola na. MC pa hoi sa nam ham. So here see. Chipen hi 160 na. Chipen hi 40 cho. Khutile aman ki ka chipen hi zat ham. Chipen hi 120 hi ngai na. So therefore this is 120. Okay. To chu step 1 na chal the ta chu. Step 1 chu pi ham. So step 1 is so net torque equals to 0. Okay. So here torque ppm na hi. So 20 pa hin anti-clockwise rotate good na. Tau 1 diute. So 5 newton pa hin clockwise rotate good ding chipen chu tau 2 diuten. So mg pa khun clockwise rotate good ding tau 3. Okay. So tau 1 plus tau 2 plus tau 3 equals to 0. Torque chu piam r into a perpendicular 20 newton pa hi axis of rotation apara khu 20 centimeter gam na. So therefore anti-clockwise to minus kala ala chun. So minus 20 by 100 into so 20 plus 60 by 100 into 5 newton plus 120 divided by 100 into mz. M into z value jong ka put dio sila so equals to 0. So you solve this. So 0 0 gets cancelled out. I have minus 4 plus 0 0 5 6 are 30. 30 by 10 to 3 na. Plus 0 0 gets cancelled out. 0 0 gets cancelled out. So 12m is equals to 0. Okay. Is that minus 1 plus 12 is equals to 12m equals to 0. Sila ko na so m is that ang ponam. So 1 minus 1 pa ko lang sila plus 1 din na sila here. So 12m equals to 1. So therefore m is equals to 1 by 12 kg. okay hoi chi pen ham so option 1 okay chi lai question azang velo chun step 1 a answer ki mojing na step 2 bol ngai lo okay next chi hi Siemens question okay tempat level sang diu na so here object of mass chan ham lai object mass 8 kg na chi pen hi mass m so it is hung from one end of the rod mama ke piket 2 kg hi mass of the rod cho chi pen hi hello mass of rod chi pen hi khat pa hi object mass ba chi pen hi and a length to 1 meter na rod length pa chu so it is supported by cable chi pen hi string cho chi pen hi this is a string so the tension in the string is okay that is the question ale chalai force of the diagram azong phate ki pida na chalai 80 newton chalang kai su ding abana cho away to middle ta am dina chalai so mass to 2 helation 20 newton chanu yam ding abana chalai fixed point ki pida cho chalai e man ki choose thei raw na chalai fixed point here so here it is fixed on the wall atile fbtc lechon free body diagram so I have a rod here so I have a rod here okay to chu mg cho lai tam na so 2 kg helachon 20 newton cho lai tam ding abana cho ning ninga khu 8 kg ki koisa chu 80 newton okay abana cho tension khu velachon batang tension pa he velachon chi tension t chu na chi so the t is not along the x or the y okay so therefore we have to split it na component langai chu chala hi so one component along the vertical chi pa hi 2 t sin 30 hong ding khat pa chu along the horizontal chi pa hi t cos 30 okay so the force the hoi velocity vertical ngan chakam chala na so that means let me take the vertical component t sin theta lang ta line so I will have this is t sin 30 aji chu butang torque formula chu pia r into f perpendicular ki dichula e one force perpendicular component pa chu ngai cha so chala he hi chipa he perpendicular lo pi chula na ro to hin velocity so this one is perpendicular okay so we have to take the perpendicular component fixed point so I am so now this is the fixed point okay so all the measurements should be taken from here mas penaso 20 hu jana gam lam so mg chu alai ta am ngai jana so total length 1 meter hil chun chi pen hi 0.5 meter abana chu khatpa hu 60 cm am na centimeter ga jute chi 50 cm ama t sin 30 hu 60 cm a ki apply na abana khat pen khu jat ha so 80 newton pa 100 centimeter ki apply so ning am ja chana okay now you have everything mg pa hin anwi langa clockwise rotate good ding tau 1 t sin theta pa kon anti clockwise rotate good ding so tau 2 80 pa hin clockwise rotate ding so this is tau 3 okay so what is the step 1 so step 1 is so net torque equals to 0 okay net torque 0 helachun so tau 1 plus tau 2 plus tau 3 equals to 0 okay tau 1 ko pi ham m due to 20 pa ko so 50 by 100 into 20 okay plus khapa ko minus de na aji chu anti clockwise rotate de ja ko t sin 30 pa kon so here I have 60 by 100 into t sin 30 chu pi sin 30 chu 1 by 2 na so I will write here t by 2 so plus 100 by 100 into 80 okay so this should be 0 just solve the na t yung pot beta so here 0 0 gets cancelled out 5 2 are 10 minus so 0 0 so 2 3 are 6 so here I have 0.3 3 t by 10 jute so plus 100 100 cancel out 80 should be equals to 0 okay so 10 plus 80 so 90 so 3t by 10 3t by 10 so transfer le na je so from here what is t so t is equals to 9 into 10 900 divided by 3 so that means this is 300 newton okay option D okay next let's go to next okay so now we have leather problem okay to cho che jai chana question hoi bela chon chai step 1 ai answer ki bojing chula na ai wang leather problem ho hi abui ne chai step ni an ni nya bol ngai cho chai okay so ama sa pena so batang leather problem cho pi ham hi ta hi bangum cho lang pya kha gal hilai bangoma chilai banga para hi chi floor na chi a floor pa he rough cho chi a chi jo smooth ala chun mi tai leather jo ta ki do thelo chula na, so the leather will slide down. Okay, as is tool just smooth ala chun na. So leather jo chala ki ngai theni nga so tool jo rough hi ngai cho. Okay, so here you have the leather. Okay, let's say this is the leather. Okay, kutile chila hi vela chun ne diu khajo chila hi mas pena cho ke su khan zo sia hena. So wherever you have contact, you're going to have normal force. So here I will have one normal due to the ground. Okay, normal n1 due to abana wall apala ho normal n2 na due to the wall. Okay, chiti lo acha friction force ang de na lei chu vela chun lei pa he chila he asot acha tool ho. So the leather will push the ground in this direction. Okay, and then the ground will push the leather in opposite direction. This is a friction force chu chila he chila. Okay, so friction force experienced by the leather na. Okay, sometimes they will give you this angle. Okay, so angle theta na. And one more thing, so the weight of the leather will be exactly in the middle. Okay, mg. So if this is x, okay, suppose this is x, then you see this mg falls like this. Okay, mg so lai ta am chala na chi l by 2 hisa chi l by 2 chala. So therefore similar triangle property na manwala chun he chi pa he na x by 2 ngiding chi pa hi x by 2 hungni cha. Okay, mg pa hen na chilang side pa hi equal undivided chala hi. Okay, so remember that point also. So the force is n1 n2 mg to f na force lita am. Okay, hi leather problem ai man dio. So now let's solve the questions. So you have a leather. The length of the leather is given as root 34. Okay, this is the length. So weight of the leather is, mass of the leather is 10 kg. So walls are frictionless hollow. Oh, walls are friction om lo jong le. Eva so two lots of friction om te ngai na. So the feet rests on the floor 3 meters away. Okay, as shown, if EF and FW are the reactions on the floor and the wall, then the ratio of the reaction is. Hutila chun reaction chila hi reaction omitiu chila na chila hi. Chi reaction pa to chun chila reaction pa hi ratio hol diu cha. Okay. So here free body diagram chila hi mang pa pi na figure pa hi. So here so I say ta bang wa chila hi n1 na tiu te. Sila ko na hi n2 Okay. So due to the floor and due to the wall na abana friction so hilang am ding ham sila hi friction na sila hi. Okay, so next thing is the weight. Okay, weight so hilang am ding ham alai ta ham na weight here. So it will point downwards. Mass to 10 kg so weight to 100 newton. Okay, kasi bang so pen hin anui lang side pen hi kitu chara divided so this will be 1.5 meter. So pen hi 1.5 meter. Okay. And one thing you need to find this side also. High zong net or head on na. Iti hold you hachila him. He chepa kipi sun Pythagoras theorem man thai chula na jila hi. Pythagoras theorem man le chun chepa h tiute. So 34 is equals to, so 3 are 9 plus h square. Okay. Chi square to hin, chi square na. So root 34 square is equals to this square plus 8 square. Okay. So root 34 square to 34 is na. 3 square to 9, but 8 square. To solve the answer po diham. So 34 minus 9 to 25. So this is equals to 8 square. So h is equals to 5 meter. Okay. So height pa to h pa to 5 meter. Okay. So now step 1 ding step 1 so bem step 1 to net torque equals to 0 na. He che torque holding to axis of rotation hol ngai chula na. Axis of rotation jo hilai la le ha jala. So here you see you can take this point as axis of rotation. Okay, chila jong na la theo. Okay, ai lo le chila jong na la theo na. Hutila hilai pen la deu ha. So here ka veda chun chila hi force ni tam chila hi. Okay, so I want to eliminate both of them. Ta chila hi tu in chila pen fixed point leng na. So if I take this as axis of rotation, so now torque due to n1 and torque due to f is 0. Okay, torque talaw na. So now I have due to n2 only, so I will find the value of nt n2 na using one equation. Kutila chila hi about he pen hi axis of rotation ilaw wala chun. So mg pa hin, so mg will try to rotate in clockwise na. So mg pa in clockwise are rotating, n2 pa in anti-clockwise are rotate litso. Okay, so let's say tau 1, tau 2. So here tau 1 plus tau 2 equals to 0. Okay, kutila torque 1 pa hitin hold ha. But torque ke bolai ba jo torque chu pita torque chu r into f perpendicular hi lo le r perpendicular into f na. So the place see the type of problem where you use r perpendicular into f is this one. Okay, later problem ho hai na torque pa hi r perpendicular into f ki bang chu chalai kutile mg pa hebla chun chi mg chula na si mg he a he chi pen hi r so kutile r perpendicular chu pi ha, so this one. Okay, so this is perpendicular to mg na chi pa hi r perpendicular ta chu chala hi chita bang chu n2 jong hebla chun n2 chu chila chi na, so therefore this is r. Okay, so therefore tang r chu pi ha axis of rotation apara force ki apply na chu chi r ki ti chula na chi he chi force he la chun r perpendicular chu chi pa hi, so this is your r perpendicular. Okay, so these two are perpendicular, right? Okay, so torque 1 chu pi ham torque 1 chu weight pa hin clockwise out rotate dingal chun plus na, so therefore r perpendicular chu pi ham, so 1.5. Okay, into mg chu 100 minus n2 pan anti-clockwise out rotate na, so r perpendicular chu pi ham 5 into force hu n2, so this is equals to 0. Okay, so ham 150 is equals to 5 n2, so n2 is equals to 5 3 or 15 30 newton. Okay, now we have found n2. Apana chu n1 hole n1 to f i hole ngai na khotile khateni hole ni ga hi net force equals to 0 banu ngai cho ma sapena chu step 2 vile chun chila have the force hi x langa jong ma y langa jong na, so therefore we have to write fx equals to 0 as well as fy equals to 0. Ma sapena chu fx equals to 0 bol chun ppm ha, so x langa hi n2 pa hi y langa chi na, so I have minus n2 plus friction force pa khozi langa chi chula na, so f should be equals to 0. So from here I have found that n2 is equals to f, so which is equals to 30 newton. Okay, so friction force pa jang chu 30 ta chu. Okay, so abana chu n1 khoi ti ki holding ham along the vertical fy equals to 0 bol chun. Okay, so fy equals to 0 chila chu y achung langa hi ppm am n1 pa chu nga chi a mg pa ha nui lang ko su na, so therefore n1 plus minus mg should be equals to 0. Okay, so therefore n1 chu janang ponam 100 newton. Okay, right, n1 n2 f bona ki munda cha. So now question chun pi do ham, so reaction ef to fw na, ef pa he pi ham ef pa he on the floor a force ni tam cho siteni resultant na hol ngai cho. Okay, so n1 is along this side, f is along this side, resultant chu pi ham, so somewhere along this side na. Vector addition formula ko man a square plus b square plus 2ab cos theta pa ko amarika angle pa hi 90 chula na, so therefore cos 90 is 0, so I will have root over a square plus b squared. So therefore reaction on the floor chu pi ha ef na, so reaction on the floor is given by root over n2 square plus f square. Okay, plus 2 into n2 into f into cos 90 is 0 na, so n2 chu zat ham n2 chu 30, so 30 square plus n1 chu ai boy n2 n1 square plus f square na, khotile n1 chu 100 square plus 30 square, so under root zat dia chi so I will have 10 9 0 0 30 square to 900, 10 100 square to 100,000 na, so this is root. Okay, chi hi value chen pi ha chi, so 109 into 100 chula na che pen hi. Okay, so 100 chu pi ham 10 square, so 10 square into, so 109. Okay, under root kutila 10 pa kong po do ding, so 10 into root over 109. Okay, so this is ef. Okay, abana chu pi ha kha chu fw force on the wall, reaction on the force reaction force on the wall chu pi ha, so which is basically n2 na chi n2 hijing, so this is how much 30 newton. Okay, question chun pi do am ratio do na, so fw by fw by chi pen hi f ve to typing mistake, force due to the floor, so force due to the floor is equals to, so 30 divided by 10 root over 109 na, 0 0 gets cancel out, answer to 3 divided by root over 109 hingai cho. Okay, ratio cho na. Okay, option 3. Abana leather problem ang last chipen he need question 2 ko makedong na. So you see uniform roll of mass 20 kg is given, length is kpm 5 meter kp na. Ale smooth vertical wall angle kp ta jula. So now theta is given as 60 degree. Okay. So the other n is raised on the horizontal floor. The friction force to equation in friction force ato na. Okay, so now you know everything na. So letter chui tayo ma. Okay. So tula para to normal pa to n1 itiyo va. Wall para normal pa to n2 itiyo na. So friction force to zilang according. So weight to downwards 200 Newton. As ito mass to 20 kg chula na. Length hu 5 meters. So total length hu. So here what else do you have? So so this is the whole thing. R perpendicular hodong ngay na chila hi. Hotel height to zat diha chila hi. So total length of the letter to 5 is angle to 60 degree. Hotel chila triangle I have chun. Chi 5 kipi na hotel h pa hezat diha. So betang chi angle hele chun opposite to hypotenuse relationship ita sine chula na chila hi. So therefore what is this? Sine 60 is what? Sine 60 to h divided by 5. Okay. So therefore h is equals to 5 into sine 60. Okay, hotele h to 5 into sine 60. Chuchu biham 5 root 3 divided by 2. Okay. Chiti lo aso tulang zang kono holo ngayon na. Tulang nga hezat ham tulang nga pa x tilo hen. So x is equals to, so 5 into cos 60. Aso ako bolta pang symbol chun cos 60 yung pod beta. So here I will have here 5 divided by 2. Okay. R perpendicular tin chun na. Okay, now hotele f holo this step 1 chup ham. So step 1 to, so net torque equals to 0. Okay. Hotele fixed point so hilai lauta. So we take this point as fixed point na. So this is the axis of rotation. Hotele mz pa khun clockwise rotating tau 1 tutin, n2 pa khun anti-clockwise rotating tau 2. Okay. Hotele tau net torque equals to 0 so tau 1 plus tau 2 equals to 0. Right? So tau 1 so piham r perpendicular ta. Nui lang apa hi 5 by 2 chula na chipen hi. Kutila half a cut de chula hi. So 5 by 4 de ta chula hi. Okay. So here I will have 5 by 4 into mz2 200 minus r perpendicular 5 root 3 divided by 2 into n2. So this should be equals to 0. Okay, so 5 into 200 divided by 4. Harpa ko transfer lejon. 5 root 3 by 2 into n2. Okay, cut the cut na. So 0 nga 5 to 5 you cancel. So 2 gets cancelled out to 100. So therefore n2 is equals to 100 divided by root 3. Okay, so pen hi n2 na. To step 2 so piham step 2 to net force equals to 0. To hi f ki to so along the x-axis boleo hen na. So along the x-axis net force equals to 0. So I have f towards the right minus n2 towards the left. So this is equals to 0. Therefore f is equals to n2, which is 100 divided by root 3. Okay, so this is your answer. Okay, it's an equilibrium problem imbolo iten na. So I think you should be able to solve questions on this now. Okay. Tilay abana hi rotational motion last topic na chicho rolling. Okay. Rolling to have motion of rigid body ball vache ball. Rolling ki dicho piha combined translational plus rotational. Na rotational to translational aunque go khoma na if it takes place at the same time. Okay, so that is what we call rolling. Okay, hechela heading so masa pena cho kinetic energy of rolling motion cho pini ha. Chela say chela translational plus rotational dio chela na. Butang translational kinetic energy cho pita. So half mv square na. Upon the rotational kinetic energy cho piham. So half I omega square. Okay. So here that means the total energy of a rolling motion will be the sum of translational energy plus rotational energy na. So piham tele half I omega square plus half mv square. Okay. Chichu total kinetic energy of a rolling motion na. Butang abana cho types of rolling hi pia rolling hi type niyum cho. So pure rolling to impure rolling cái tí na so ai hon lang pia question cái tông hoi vela chun pure rolling ngan chang cái tông ve to chela he pure rolling chu piam tele there is no sliding between the object and the ground he chi rigid body pa chun na ground ki ka chu sliding ma cham lo tin cho okay in that case we call this as pure rolling na ai va sliding a hong ma ke thol na rigid body chu ke pai jong ke pai ai va chu ke thol na au ma la chun so if sliding occurs then that is impure okay tele to hi pure rolling chu tu ka sei banga chuna lang pe question zo si pure rolling en chang cho so pure rolling apart from ala chun ma sepen an hedu chu so v is equals to omega r hi pa hi ke satisfy cho proper rotation omja chuna so omega equals to v by r hi ke satisfy ana so a is equals to v square by r bola hola na so but most of the questions are based on this only okay so omega equals to v by r sepen email chilo chun motion of rigid body polva so say da na wheel hita ma chelai velocity 2v is a chelai 0 tai bol na chelai so okay so that is a rolling motion okay so I say bang kinetic energy of rolling motion so piham so half mv square plus half I omega square na chelai him so tang ke total so piha so half into I omega square plus half into mv square ki di chuna chelai him Hello, so is it the bang so half mv square plus half I omega square. Okay. Kuti let's say half mv square into plus I hi biha. But radius of gyration in bolo na so radius of gyration so biham tala mk square chuna. So you equate whatever rigid body moment of inertia about the given axis. Okay. Hechi rolling I vela chuna pa sia rolling hina lang pia about the center of mass ibe to so most of the rolling takes place about the center of mass na whatever moment of inertia about the axis of rotation we equate to mk square hita here radius of gyration in whole na here so therefore in place of I can write mk square here okay so half into mk square abana omega so tika jethya v by r na here so therefore v square by r square Itin bowling pita half mv square common na half mv square common kala dolation so 1 plus k square divided by r square okay so this is the total kinetic energy okay abana so rotational energy cho biham so half I omega square chalai par hai na hilai bol pen ho chalai hai ichi gabela chun so what is ratio hole to chalai hai total kinetic energy cho chi na ji ang podo dan chu ka solve is na chalai hai so here the ratio of translational, rotational and total kinetic energy will be ipidha. So half mv square to translational na is 2. So rotational to piha. So half I omega square na. I omega square to I khela to mk square kaji thai na omega khela to v square by r square kaji thai na chala hi. Khudela chi ga rearrange le chun I can write like this. Half m v square k square by r square. Okay. So is 2. So half m v square now 1 plus k square divided by r square. Okay. Hichalai vela chun tam zo si half mv square cancel leo chun I piung pot di ha chi ratio hiung pot cho chi hi. So you can remember the ratio tin by ha jing to. Rotational part cho half mv square k square by r square na. Abana total acho 1 plus k square by r square hungum chala na chi. So this is the ratio of translational is to rotational is to total energy. Okay. Right? As you k hi vitang k hi radius of gyration head vala na so k hold on to hollow pitch. Okay. So if you can find k then the ratio will come by itself. Okay. Kasi banga chu chala hi rotation ho na rolling ho lang pia about the center of mass ngen jang dia na k hold on to hollow cho. Okay. So next place next point very popular. Okay. Popular ta rolling down inclined plane na this bang hollow sphere bang ring bang so na thumung ke peding if they roll down the same inclined plane so which one will reach the bottom faster di hovel na which one will take the less time to travel di hovel ke dong so na ji khutile rolling down inclined plane ading ai poi mo so na ji jo derivation kan bolo jo hitin by having the formula hi okay that is better ji jo exam ading a mark mo na so na answer attempt na pen so poi mo pen so le hoding a so okay so for you derivation everything is not important okay understanding ani a so derivation bol thai jai song le ngai ka sa be se lo na jela hi v cho piham so 2gh by 1 plus k square by r square hi chi pen hi formula do se jaw eta So 2gh by 1 plus k square plus r square to velocity na speed velocity of the rolling body inclined plane na abana chu with the height hi inclined plane chu tia mala chun so if this is the inclined plane, okay, hi chi pa hi angle theta ngi ding hi chi hi length na total length abana chi pa hi height, okay. Hi chi la h man pa na velocity formula h pa hi chi height ke sei nei cho abana acceleration a hi theta pa hi inclination angle pa chu na chi hi so acceleration chu piham z sin theta divided by 1 plus k square by r square. To amasanga kinematics of speed formula no here chala root gh na chipen chu hitsun by hal lechun abana acceleration chu inclined plane acceleration chu ipita z sin theta chula na masanga loss of motion involve chu. Okay, so the only thing that you add is divided by 1 plus k square by r square chila divided by 1 plus k square by r square chu hising hitsun mel chilechun. So this is the velocity of the body and this is the acceleration of the body. Question am to khazen jana lechun. Okay, so next you have time taken. Hichipen here so which one will reach the bottom fastest at the time depending na less time ala chun malhun di nai cho. So here the time is what 1 by sin theta, so 2h by z, so 1 plus k square by r square na value chun 1 plus k square by r square kita chu chalai jong here. Okay, so this is the time taken na kutile chalai he di chu a body with a time hi value chun mass ajong ke depend low, so you have height and everything to chu rigid body ni le thum chu na same inclined plane a ke hala chun, so that means theta will be same. Okay, so 2h by z everything will be same, the only difference is k will be different. This keto ring keto sphere kya chu ke banglo chula na chilai chu. So if they give you this different values, then you just find the value of k. Okay, put it here, you'll get the value. So same inclined plane hi ala chun hi chi to hin chi bona ke bang chu. Okay, so for example you see here a body with less value of k square by r square. Na k square by r square pahin and appo so it is responsible. Okay, it will tell you which whether it will reach the ground faster or slower. So a body with less so hichi alhom chana chu na alhom chana chu it will take less time to reach the ground gang di ne cho k square by r square value anyim chana chu na, so it will take lesser time to reach the ground. Okay, chicho example aga value hen suppose you are given a ring. Okay, ring chu bata chalai k square by r square holan kan vet sa cho, so ring chu moment of inertia chu piha, so 2 mr square chula na moment of inertia cho, so equate this to mk square hodele r square by hola transfer lechun, so 1 is equals to k square divided by r square. K square by r square value is hala hi 1 na. Okay, abana hu next body hu piha, so disk na, so this hi moment of inertia about the center of mass piha batang this to a key roll alchun, it will roll about the center of mass na, the whole thing rotation will take place about the center of mass. Okay, this also mr square by 2. Okay, so equate this to mk square, cancel out, so r square hukla transfer lechun, so 1 by 2 is equals to k square divided by r square. Okay, 1 by 2 so pm approximately 0.5, exactly 0.5 na chichu tinga ko ite this na abana chu pm abana chu hollow sphere. Okay, hollow sphere is given, hollow sphere chu is at 2 by 3 mr square na, 2 by 3 mr square is equals to mk square. Okay, radius r square hola transfer legend, so 2 by 3 is equals to k square divided by r square. So this is how much? So 0.66 na 0.66. Okay, atile abana chu solid sphere so piham 2 by 5 mr square na, so 2 by 5 mr square is equals to mk square. Okay, kotile 2 by 5 is equals to k square divided by r square, so 2 by 5 to piha 0.4 na, so here I have 0.4. Kutila 2 hin k square by r square value pa value chun huya huichi pen hin thom pe na, so solid sphere thom pen na abana chu huichi pen 0.5 this ka na abana chu hollow sphere achaina kena chu ring. Okay, so that means solid sphere pa hin it will take the less time to reach the ground. Okay, abana chu piha abana chu disk na, abana chu hollow sphere, abana chu ring. Okay, so this is the order. So solid sphere will take the less time. Okay, abana chu disk, abana chu hollow sphere, abana chu ring na chita banga so acceleration formula che apply bola chun k square by r square value so okay na chala he cha ta so see all this will be the order. Okay, you can check it your using this formula na. Okay, but then k square by r square alhom chana so na alhom chana so piti ha chala he. So if the denominator gets lesser, then the overall value increases. Okay, denominator value so nim chana so overall value so tam ne na cho kutila chun speed pa so tam pending na, so time pa so less pending, speed pa so tam pending, abana acceleration so tam pending. Okay, so this is the order na. Value chun alhang pia formula zo si hi ipia ki depend am tele k square by r square ki depend so. Okay, hitai ka vek ka bol banga he na k square by r square holdan pen holdan pa he na ki ti longai cho, because most of the questions will be based on this. Okay, so we'll quickly solve some questions based on this. So a solid sphere, okay, solid sphere is rolling without slipping. This is pure rolling. The ratio of the linear kinetic energy, this is translational kinetic energy na, and the rotational kinetic energy is as our ratio to pitam 1:2 k square by r square is to 1 plus k square by r square. Na eventually question ahi translational patohin rotational pabos eto so jiteni bos he. So you put the value solid sphere ki pichula k square by r square chuzat ha. Solid sphere to 2 by 5 mr square. Okay, so this is what mk square. Gets cancelled out. So 2 by 5 is equals to k square divided by r square. Okay, so value pulachun. So 1:2. So 2 by 5. Okay, so multiply both sides by 5. So 5 is 2. So this is your answer, 5 by 2. Okay. This is Siemens 2025 question. Abana chu another Siemens question. A solid uniform solid cylinder na mass m radius r rolls along inclined plane theta ki picha jala hai. So theta is 45. Question pidam if it starts from rest chunga pala na and linear acceleration of the cylinder will be acceleration direct question ki dong na jala hai. Ye formula chu piham. So here z sin theta divided by 1 plus k square divided by r square. Okay, kutile solid cylinder chu moment of inertia chu pita this ato ki bang chu na chu mr square by 2. So this is equals to mk square. Kutile r kholang ho chil chun 1 by 2 is equals to k square by r square. Okay, tun value jo si chu put leu chun z chu piham answer khu in terms of z am na z value put ngai lo. So sin 45 divided by 1 plus 1 by 2. Okay, k square by r square value jo pull leu na jala hi. So here I will have sin 45 to 1 by root 2 na. So z by root 2 bana chu anu ya khu is ha 3 by 2. So 2 goes up, so divided by 3. Okay, so root 2 gets cancelled out. So final answer is root 2 into z divided by 3. Okay, so option D. Okay, option I is equal beta jala z value ho hai na. So root 2 into z by 3. Okay, next a solid sphere. Okay, solid sphere to PKPM hollow sphere kipi na jala hi. So of same mass to same radius are roll in inclined plane. Let the time taken to reach the bottom by the solid sphere to t1 na. Abana hollow sphere to t2. Khutile which pen hi lung masariam kitong cho na option evaluation less than greater than kiti chula azo I say bang ma chu k square by r square value of home pen chuna. So it will take lesser time. Okay, k square by r square value of home chana chu a time chu less didna chu khutila chun chiteni ka hi k square by r square pen ku ya pen home zom na value chu. Okay, so for a solid sphere, so what is the moment of inertia about the center of mass? 2 by 5 mr square. So this is equals to mk squared. Okay, m cancel out. So 2 by 5 is equals to k square by r square. Na ji chu zat ham 0.4. Okay, abana hollow sphere chulale hollow sphere chu 2 by 3 mr square. So this is equals to mk square. Okay, m gets cancel out. Kutile chun 2 by 3 chu piham. So k square divided by r square. Chi hi 0.6. Kutile 0.4 to 0.6 chu which linzo. So this is t1, this is t2. Na hollow to t2. kuti le value chun t1 in hom zo chula na so k square by r square value chun nim zo tin so so here you'll have t1 less than t2. Okay, so option A. Next a solids question here. So we have only 2 more questions. A solid sphere of mass m, radius r, is allowed to roll without slipping. Okay, from the highest point of the plane, length to L kipina, plane length. So kasi mga so inclined plane to tehem so. Okay, so that means this is 30 degree. Question na kipi ho sipen hi L na. Okay, so the speed of the particle at the bottom is v1. Okay, so speed v1 na sila ko na hong kisu also speed to so root over 2gh by 1 plus k square by r square. So first case also speed to v1 if the inclination is increased to 45. Second case also ita here 45 umtana chila here. So again this is still L. Okay, atila chun chila here. So first case also speed to v1 na, second case also speed to v2 so then the new speed v1 square by v2 square ratio kidong so. Okay, speed I have speed I have h na height. So this is h1. So this is h2. Okay, so h1 will be what? L sine 30. Okay, h2 to be L sine 45. So this is opposite na. Hypotenuse opposite to hypotenuse relation to be sine. So what is sine 30 here? So sine 30 is h1 divided by L. Okay, so therefore h1 will be L into sine 30. So how much is this? L by 2. Okay, sipahi L by root 2. Kutile v1 square by v2 square bolajun. So v1 square by v2 square. Hol masaute. v1 to biham. So v1 square to so 2z into h1 divided by batang jilahi. So it is the same solid sphere. Okay, so the same solid sphere is rolling down in 2 different cases. Jija chu jilai anui lang pa hai na. For both the cases. Okay, 1 plus k square by r square h1 bogi kita na jala. So here I will have 2z. Okay, so divided by 1 plus k square by r square. It in bracket ko itong kating jala h1. Okay, sita banga chu v2 square jo piham. So 2z into h2 divided by 1 plus k square plus r square. Okay, achung ata bang ako. So 2z divided by 1 plus k squared by r square into h2. Tunti divide bola chun pim pot diha. So divide bola chun tam din pa cancel din na. So you'll be left with h1 by h2. Okay, h1 ko piham L by 2. h2 ko piham L by root 2. Okay, so finally what will you have? So I will have here 1 by root 2. Okay, so root 2 gets cancelled out. So root 2 is remaining in the denominator. So option is C. Okay. Hotele China pending in. So solid sphere kipina chila. So in rolling motion, a body possesses a translational kinetic energy as well as rotational kinetic energy. Question P doham KT divided by KT plus KR. Na KT divided by KT plus KR. Okay, translational plus rotational kitina. So chipen hi pikisina. So this is basically total kinetic energy. Okay. Khutila ratio chu hero jala na. Translational is to k rotational is to k total chu piha. 1 is to k square divided by r square is to 1 plus k square divided by r square. Azo melchi vingati pa na chi. So here we need to find out this and this ratio chu na. So 1 is to 1 plus solid sphere ki pichula solid sphere chu piha 2 by 5 into mr square. So this is equals to mk square. Okay, m gets cancelled out. So 2 by 5 is equals to k square divided by r square. Kutila zara 2 by 5. Okay, so that means 7 by 5. Nah, multiply both sides by 5. So here you'll have 5 is to 7. Okay, so option B. Okay, that much. Rolling motion question kitong hoy na lang pe chita bangin chang isa. Abolo nga formula ka pi ho sa MLC leuchun. Okay, so then you will be able to solve it. Okay. Hechi hoy na speed formula has a acceleration formula has a chukil time formula pa hai na. Okay. So with this, rotational motion is complete. Okay. So I hope you understand everything. Banapan ako rotational so para hi gravitation na next chapter who gravitation involved. Okay. So we'll end up here. See you in the next video. Thank you.